So guys, under this recording, I want us to discuss elasticity, right? So yeah, you guys know that there are many definitions, so but I'll be showing you which ones are mostly important, and then we're gonna discuss the type of strain and the type of stresses that objects will go through when a force is applied on them. So here we see that we have this term on your slide, rigid body is the first term. So this is just a So when talk about rigid body, they are defining as what defined as a body on which let me increase the font. It's defined as a body on which the 2 points never changes, whatever force is applied on it. So a rigid body is just any object whereby if you apply a force on it, its shape is not going to change. E.g. a rock. No? Yeah, if you apply a force on a rock, its shape is not gonna change, right? And that's why here we've got this guy. So it's just this is the rigid body, right? And then a deformed body. This one is an object which by if you apply a force on it, its shape is going to change, such as the what I think this was the tennis. So if you squeeze it, obviously there will be a change in shape. So that's what we call it a deformed body. So they define it as a body on which the 2 points changes under the action of some forces when applied on it. Right? So that's a deformed body. So we've got a deformed body and we have a rigid body. So even the terms they explain themselves. This one there will be a change in shape. This one there won't be a change in shape. And we move to the most important term, elasticity. This is the property of a body by what? Okay. So this is the actual definition that you have to know for a test. So you're gonna define it as the tendency of a solid material to return to its original shape after the applied force is exerted on them. So this is the formal definition that you must know. And then when the forces are removed, the object will return to its initial shape and sizes if the material is elastic. Uh, yeah, so these are examples of what of elastic materials. Steel cables, rubber bands, strings are examples of elastic materials. So you must be able to know them, right? In multiple choice, they can ask you. So any material that which you know that if you apply force on it, its shape is going to change. It's an elastic material. So I don't know if I should be writing this side that you guys can. So I'll just write here. So let's write the examples of elastic materials. We're talking about rubber bands. We're talking about plastics. Uh, let's see what else we are having. Also talking about what else did they write there? Plastics are types of elastic materials. A spring. This one is the most common example that they usually bring in a multiple choice. So if they bring spring, they say select the type of elastic material. This one definite, but even this one's right. So yeah, we've got what we call an elastic material. It's a material that which if you apply force on it, there will be a change in the shape of our object. So we also have inelastic materials. So those ones, when you apply force on them, there won't be a change in shape, right? Then I've got what we call, there is this term here. Oh, and also there is a term called plasticity, right? I almost forgot about it. So we must understand what is meant by the term plasticity. Plastic. So these ones are materials that which if we apply force on them, they're gonna change permanently. So let me write it here, the definition here. Materials. So let's use materials at which. So this one is the opposite of elasticity. The opposite of elasticity. So just negate the definition of elasticity. So we define elasticity as materials that which will permanently change in shape. No? Permanently change in shape when a force is applied on them. So, but for elasticity, so with elasticity here, we say this, they say the tendency, so let's write it in right this one so that you can see. It's the tendency of solid materials to return to their original shape, to its original shape. So with elasticity, the material will return to their original shape when a force is applied on them. Yeah, and then let's move to other terms. So these two, they are very important, right? They can ask you to differentiate between plasticity and elasticity. So now let's check the other things there. We're on stress, right? We have a new concept called stress. So this one we have what we call stress and what we call strain. So those are two different things. So stress is the force applied or system of forces that tends to deform the board, right? So that's how you will define stress, and the symbol for stress is denoted with sigma on your slide. Uh, so here with stress, we're just checking the rate at which the object is changing, right? Yeah, the rate at which the object is changing. So by this strain, we're checking how much is the object changing. So stress is defined with this formula. So when you define stress, the formula for stress is force per unit area. So this one you have to know it. They might not even give you. And then the units for stress, that's what is pascals. So the units for stress is pascals or Newton per meter squared. So if they say calculate stress, let's say you get 100, you say Newton per meter squared. So you must make sure you write the units. So the units are same as what? As the ones for pressure. So you must know that stress and pressure, they have the same formula, right? Force per unit and pressure is force per unit area. Now we've got types of stress. So we've got three of them. So we've got what we call normal stress, we've got what we call tangential stress, and we've got what we call bulk stress. Hmm. So this statement is very important. It's saying that the stress that is developed on a boat, it depends on how much the external forces are applied on it, right? So obviously, the way the object is going to change, such as this rubber band here, it will depend on how much force are you applying on those rubber bands. If the force is too much, obviously, the object is going to break. So also have a graph, né, that you must know uh, while I'm still here. But then the graph looks something like this. So somewhere there we put the breaking point. So we'll check the graph later on. I don't think this slide it has it. So that graph is important. They usually ask questions on what? On multiple choice. Yeah, almost forgot. We've got the graph on multiple choice. They usually ask. They will say this is point A, this is point B, this is point C, and then they start asking